Let us consider fractional distillation. Fractional distillation method can be used to separate the mixture of two or more miscible liquids with relatively close boiling points into its component fraction. This is different from simple distillation that we explained before. For simple distillation, we can use it to separate miscible liquid that have wide boiling point difference. That is, wide difference in boiling point. But here, the mixture will have close, or the liquids in the mixture, they will have close boiling points. This method is widely used in industries, such as refinery industries, to separate the fractions of petroleum. And it is also used in nitrogen industry, industries where they recover nitrogen from air, to separate the fractions of air, to recover nitrogen from air. So the fractional distillation process is more complex than simple distillation process. As the name implies, it means we have to have different fractions in the mixture. Like petroleum, we know that petroleum is made up of a lot of different components. So all of the fractions of petroleum, such as petroleum gas, lubricating oil, paraffin wax, gasoline, diesel, bitumen, can be separated using this method of fractional distillation. So this is how the setup looks. So this is a simple setup of fractional distillation. It is used in the refinery and big industries. Now, here we have the fractionating tower, or we call it the fractionating column. Now, here we have the inlet of the crude oil. The crude oil will be passed into the fractionating column through this inlet. Then, the fractionating column will be heated from the source of heat, to be heated heavily. Now, by the time the temperature gets to 20 degrees Celsius, the fraction of petroleum that boils at 20 degrees Celsius will be recovered. The vapor will come out through this point and be condensed in its own container separately. And we will continue with the heating. Now, after 70 degrees Celsius, petrol boils at 70 degrees Celsius. The vapor of petrol will also be collected in another container. So, and then it will condense inside the container to form our normal petrol. Then the next one is naphtha. It boils at 120 degrees Celsius, followed by kerosene, 180 degrees Celsius, followed by diesel, 260 degrees Celsius. Next, lubricating oil at 300 degrees Celsius, fuel oil at 350 degrees Celsius. Then the residue will be left in the fractionating column and later will be collected out. And this is used as bitumen and asphalt for road construction. So this is how the setup of fractional distillation looks. Similarly, for fractional distillation of air into its component gases. Here we have the setup for fractional distillation of air. Now, this is the fractionating column, and this is the condenser, the condensation part. The air will be, this is the inlet of the air. Air will enter into the instrument. Air will enter into the setup through this point. And then at this point, air will be turned to liquid. Then the liquid will be passed to the fractionating column where it starts boiling, where it will be heated. And then the gases will be collected separately. After when each one of them reaches its boiling point, then they will move out of this and be converted to the vapor of the gases. Now, here we have nitrogen first, followed by argon, and followed by oxygen, according to their difference in boiling points. Thank you.